Hello everyone. This video I'm going to show you the example of simple harmonic oscillation, and it's use the energy approach. Okay, here is the simple harmonic oscillation system. They say the mass is 0.5 kilogram, and the force constant of the spring is 20 Newton per meter. And then using the energy approach, okay, first of all, calculate the maximum speed of the card if the amplitude of the motion is 3.0 centimeters. Okay, so okay, let me say, okay, so I'll use this blank page. Okay, so what's the information? What's the information from this problem? It said the mass is 0.5 kilogram, right? Yep. And the force constant is 20 Newton per meter. Okay, and now he said the amplitude is 3 centimeter. Okay, he say first of all he say find the velocity maximum velocity. Okay, right? But first problem is find the maximum velocity, right? Yeah. Okay. Okay, so for energy approach, we need to know is the total energy of the system is equal to 1 over 2 k times a amplitude square, and equal to the kinetic energy plus potential energy, which is 1 over 2 mv square plus 1 over 2 k square. Okay. Okay, so what's how we want to find the V maximum? Okay, velocity. That looks like we have to use the kinetic energy. Okay. Okay, at the V maximum, we say at the V maximum, that means we have the kinetic energy maximum. Okay, so in the previous video, I say in simple harmonic oscillation, the kinetic energy and potential energy interchange to each other. Once you have maximum kinetic energy, at the meantime, you have minimum potential energy, minimum elastic potential energy. That means is zero. Okay, so by using this concept, so 1 over 2 Ka squares equal to 1 over 2 m and V max square. Okay, so okay, it's very easy. So we have information of K. Yes, we have amplitude. Yes, okay, we have mass. Yeah, we can solve the V max out. So this can divide it, this can cancel into each other. So K is equal to 20. And amplitude is 3 centimeter, but be careful, we have to put every physical quantity in MKS system unit, okay? So we have to change the 3 centimeter to 0.03 meters. And the mass is 0.5 kilograms. And the V max square we can get, okay, so what is the V max? I think using your calculator, V max is very close to 0. Let me see. I always forgot this. I always forgot this square. Be careful for the square. Easy to miss the square. Okay, 0.03 square times 20 divided by 0.5, and then take a square root. So it's very close. It's actually 0.1897, but it's probably close to, I think the answer from the textbook is 0.19. Okay, the meter per second. Okay, so that's the first problem. Okay, what's about the second problem? Second problem, us look back the problem. What's the second problem? What is the velocity of the car when positioned at 2 centimeter? Okay, the second problem is if the x at 2 centimeter. Okay, what's the velocity? What is the velocity, right? Velocity? Yeah, okay, velocity. What is the velocity? The velocity. Okay, what is the velocity? Okay, so with this thing, using the energy approach. Okay, so the total energy is equal to 1 over 2 Ka squared. Okay, and it's equal to kinetic energy plus the potential energy. Okay, So the amplitude right now, the amplitude, the problem didn't change the amplitude, So amplitude is the same. Okay, so 1/2 k is 20, amplitude 0.03, and be careful square. And what's the velocity at this point? Because the total energy doesn't change, so that's the total energy. The total energy of simple harmonic oscillation doesn't change. So let's just write this 1/2 times 20 times 0.03 squared. And also, it's equal to total energy doesn't change during the harmonic oscillation. Total energy never change. So what's the velocity? 1/2. The mass is 0.5, and the velocity at 2 cm, I don't know. So let's just make it is unknown. Okay, but and the position. Do we have the elastic potential energy in this problem? Can we get the elastic potential energy? Yes, we can, because it give you because it give you the position right at the when the position at 2 cm. I think this 2 cm it means plus 2 cm. Okay, so let's put 0.02 square. So we have one equation and one unknowns. So of course we can solve the V at 2 cm out. So the answer V at 2 cm is, okay, let me do a calculation. So first of all, 10 times 0.03 square and minus 0.5 times 20 times 0.02 square. Okay, and yeah, oh no. So I have to times 2 divided by 0.5 and the square root 0.141. Okay, 0.141. Okay, so we will have two answers. One is plus minus 0.141. Then the unit is meter per second. Okay, because it's square. Okay, so we have two answers. It's positive or negative. The positive and negative. Okay, so let us see. Okay, if okay, let's look back these figures. Okay, that's why we need this figure to answer the problem 2. Okay, the problem B. Okay, so it said okay, for example, it said the amplitude is 3. So here is 3. Amplitude is 3, and then it said the velocity of the car when the position at 2. So that means it's somewhere here. Okay, I just say the 2 means is as plus 2. Okay, if this is the dashed line is equilibrium position, the dashed line is equilibrium position. The 2 is here, and the amplitude 3 is here. So 2 is here. So amplitude 3 is here. So at this point, because I think he's doing the motion to the left. At the position at 2 centimeter, he's doing the motion to the left. So the velocity should have the negative value. Okay, so back to this problem. So plus minus 1.41 meter per second, which we have to choose. So based on the graph, pick a negative one. Negative. Okay, so it's negative 0.141. Okay, so that's the second problem. Okay, what's the problem C? Okay, problem C is compute the kinetic energy and potential energy of the system when the position occurs at 2.0 centimeter. Okay, just do it a little more further. Okay, what's the kinetic energy and potential energy at that particular point? Okay, so for kinetic energy, yeah, it's very simple. Okay, kinetic energy is very simple. Okay, potential energy. Okay, yeah, potential energy. Yeah, here. Potential energy is here. This is potential energy. This is U spring. This is the potential energy. And what's the value of this? Okay, so 0.02 square times 20 divided by 2. So it's 4 times 10 power minus 3, and unit is joule. Okay, and what's the kinetic energy? Actually, just put the velocity here and doing it 1/2 times 0.5 times velocity squared. That's the answer. Yeah. Okay, so 1/2 times 0.5 times minus 0.141 square. What's the value? 0.141 square times 0.5 divided by 2. It's not very good looking answers. Okay, so let's see, do he have better answer? Let me see. 0.03 square times 20 divided by 2 minus 4 times. Okay. Because the answer of, if you calculate the kinetic energy directly, the answer is not really good looking. So we use another way. We just use because of the numerical issue. So let's use the total energy minus the spring potential energy and equal to the kinetic energy. Okay, so we have spring potential energy 4 times 10 power minus 3 joule. What's the total energy? The total energy is 1/2 times k times a squared, right? So 0.03 square times 20 divided by 2. So it is 10 to power minus 3 joule. Okay, so what's the kinetic energy? The kinetic energy actually is 5 times 10 to the power minus 3 joule. Okay, and I think that's the answer to the problem C. Okay, so yeah, this is again using the energy approach, okay, to do the calculation of simple harmonic oscillator. Okay, so when the next problem is if we change the initial condition, let's see, if we change the initial condition, change the initial condition. Okay, it said the initial position is at x equals 3. Yeah, it's initial position, not amplitude. Okay, initial position is 3 and not amplitude. And it changed the initial velocity to 0.1. And find out the new amplitude and maximum speed of the cart again. Okay, so that's well, we'll use the energy approach once again. So okay, but we will do this at the next video. Okay, because I want to make video too long. Okay, see you in the next video. Bye bye. Wow, very long. Over 30 minutes. Not